Hey everybody, it's Mr. Jones. I am back, hopefully to help you out with some things. I printed out the STEM Scopes reading. It's only 6 pages of reading, but if I'm being honest with you, it is 6 pages of very heavy, kind of hard to understand if you don't know any of this stuff. So I figured maybe I'd help you guys out, make a little video, add some PowerPoint slides, and we'll get through this stuff together. Starting on page 1. On the very top, it says, reflect. Some waves need a medium to travel. That sentence is in bold. However, it means nothing to us if we don't know some basic vocabulary words, such as what is a wave and what is a medium. So that'll be the first thing that we talk about. So when we think of the word wave, we usually picture someone waving. Or you think about going to the ocean and seeing the water crash into the beach. But those aren't the kind of waves we're talking about right now. We're talking about physics waves. A wave is a disturbance that travels through a medium. The medium is the material that the waves travel through. Mediums can be air, water, steel, wood, or, as we'll find out in the future, the vacuum of space itself. Now that we know what a wave is, or at least a little bit better than what we did before, and you understand what mediums are, let's dive into this reading and see if I can make it a little bit clearer with some PowerPoint slides and some verbal explanations. There are 2 types of waves we are going to be talking about. Mechanical waves, or waves that must transfer energy through a medium, such as sound, and electromagnetic waves, or waves that can transfer energy through empty space. Those things are the electromagnetic spectrum, like radio waves, microwaves, ultraviolet waves, X-rays, and visible light. Mechanical waves must have some sort of matter or medium to travel through. Some examples of those different mediums could be air, ocean water, land, violin strings, and slinky coils, etc. These waves travel when the molecules within this medium collide with each other and pass that energy on from molecule to molecule. Sound is an example of a good mechanical wave, and sound can travel through solids, liquids, and gases, but not the vacuum of space. We'll be able to see these sound waves travel through the air with the help of Thor, so check this out. So what we're looking at here is a graphic representation of the sound when Thor headbutts my water bottle. The speedometer looking device at the bottom measures the decibels, or how loud that sound is. And then if you look at the top, you can actually see the sound waves. Now remember, waves are created when a source or a force generates a vibration. In our case, that vibration or source was Thor's head headbutting the water bottle. Another cool thing about sound waves, or light waves, or waves in general, is that the speed in which they travel depends on the medium that those waves are traveling through. If you think about fireworks, think about how you can see them before you can hear the sound from them. That's because no matter how loud those fireworks are, that sound can only travel at 343 meters per second through the air. That's opposed to the 299,792,458 meters per second light travels. This chart shows the speed in which sound travels through different mediums: air, water, salt water, rubber, and iron. Looking at the chart, which state of matter do you think transfers sound waves the fastest, and why? As you think about that, look at the pictures on the screen and remember that the particles within a solid are tightly packed together and just vibrate in place. The particles in a liquid are looser and can move around, and the particles in the gas move around completely freely. So with sound, as a source of energy begins the vibration of the wave, the matter around that source is disturbed. Each disturbance is passed from the one piece of matter to the matter next to it, so the energy flows away from a wave source. So if we think about how tightly packed solids are, it's easier for that sound wave to jump from particle to particle because they're so tightly packed together. When you think about gas, they're so spread apart that sound moves slower. So hey everybody, I know these videos are taking me a long time to get up and some of you have been waiting for them, so I thought I would post this first few minutes of this one. I will get to the rest of the reading today and post a video hopefully by Saturday evening, and then I will get on to the next reading videos right away. I'll try to keep them updated and coming as quickly as possible to keep you guys interested and help support you in the online learning. If you're enjoying these videos, let me know. Also, if you'd like to see something, if you want me to do something or try to show an experiment, or you're just curious about things, reach out and tell me, because I will gladly try to do some videos to keep your interest up. And we're having fun with them. So get some studying done. Enjoy your weekend. We will talk soon.